Now, as you saw in the previous video, finding the particular solution can be quite tedious, even when the right-hand side is pretty simple. So oftentimes I'll ask, or on the exam, I may only ask you to find the form of a particular solution. When you're given a non-homogeneous second order linear differential equation. And so what that means, if I ask you to just find the form, you write down the general solution and you do not have to determine the coefficients. So when you see this, that means you do not have to determine the coefficients. Now, let's keep in mind the two cases of the previous page, and you may want to keep your printed out notes for the details here, but I'm going to just write the two general cases that we're looking at. So we're looking at either f of t is of the form c times t to the power m e to the power rt, or f of t is something that looks like c times t to the power m e to the power alpha t sine beta t, or c to the power t, or c times t to the power m e to the power alpha t cosine beta t. So those are the two right-hand sides that we want to compare this to. So let's also take a look at the homogeneous version of this differential equation, because the solution determines in part on what the roots of the auxiliary equation are. So for this differential equation, we know that the auxiliary equation is equal to r squared plus 2r minus 3 equals 0. And that factors as follows: r minus 1 times r plus 3 equals 0. So r minus 1 equals 0, or r plus 3 equals 0. And so r equals 1, or r equals negative 3. So right off the bat, we see that the auxiliary equation has two real solutions. So when the right-hand side has a sine or a cosine, we never have to worry about that t to the power 1, because alpha plus or minus beta I is a complex root, and there are only real roots here. So let's take a look at part A. So for part A, we have 7 cosine of 3t is our f of t. So we're going to compare that with this form right here. So we're going to compare that with c t to the power m e to the power alpha t cosine beta t. Okay, now we see that c equals 7. Again, this is not important because it's not going to be part of our solution. We don't see a power of t in front, so that means that we can write this. We can actually write this as 7, and then I'm going to write this as t to the power 0, right? There's no t, that's just a hidden factor of 1. And then there's also no power, no e to power, so I can write this as e to the power 0t, right? That's another hidden 1. And then finally, I have my cosine of 3t. So what are all our values? We see that m is equal to 0, alpha equals 0, and beta equals 3. So we have to compare the roots of the auxiliary equation with the root here. So alpha plus or minus beta I, that's 0 plus or minus 3i, or just plus or minus 3i. And that is not part of the auxiliary equation. So our conclusion is that not a root of the auxiliary equation. So that means that our S is 0. And so the general form of our differential, or of our particular solution, is yp of t is a naught, right? Because our polynomial only has one term, times e to the power 0t times cosine 3t plus, and then the polynomial with the b's as the coefficients, that's also just going to be a b0 times e to the power 0t sine t. And then, of course, we can simplify that as yp of t is a naught cosine 3t plus b naught sine of 3t. Should be a 3 here. Okay, let me clean that up a little bit. So that's our final answer for part 8. Yp of t is a naught cosine 3t plus b naught sine 3t. Okay, the next one, we see that f of t is 2t e to the power t sine of t. And so we're going to compare that with this one right here, but just with a sign. So we're going to compare that with c t to the power m e to the power alpha t sine sine of t. Okay, now here it's a little bit easier to see, I think, because we have a t, we have an e, and we have a sine. And so that's sine beta t, right? So I'm comparing that with sine beta t. So let's not worry about c because that's not going to show up in the answer. So I have that m is the power of t. And so that's t to the power 1. So m equals 1. And then alpha is the value in front of the t here. That's a 1 as well. So I have alpha equals 1. And then finally beta, that's the value in front of the t. So beta equals 1 as well. Now let's take a look at the complex root. Alpha plus beta I plus or minus beta I. That now is 1 plus or minus I. And again, that's not a root of the auxiliary equation. So our conclusion there is that S equals 0 as well. And with those values, our particular solution now looks as follows. Yp of t equals, we have to have a polynomial of degree 1. So that looks like a1 t to the power 1 plus a naught. Then e to the power alpha t, which is just e to the power t. And then we have, well, we can start with sine or cosine, but let me start with cosine. And then cosine of beta t, so that's cosine t. That's our first part here. And then the second part is polynomial in t again, but with different coefficients b1 and b naught, and then e to the power t sine of t. And again, think of the one here, the one here, the one here, and the one here coming from here. And that is our final answer for the form of the particular solution. Again, we don't want to plug this into the differential equation. That's going to be a lot of work to figure out what the values of a naught, b naught, b1, and a1 are. Okay, the third one is t squared cosine pi t. So now we're going to compare t squared cosine pi t. And again, we're going to have to compare it to this one. So I'm going to compare this with c times t to the power m e to the power alpha t cosine beta t. Not worried about c, so let's take a look at what is m. That's the power of t, and we see that that is equal to 2. Then the alpha t, there is no e to the power here, so that means alpha equals 0. And then beta is the value in front of the t, and that's a pi here. So beta equals pi. Real quick, alpha plus or minus beta I, that's 0 plus or minus pi times I. That's not a root of the auxiliary equation. So again, we have that s is 0. We don't have to multiply by a power of t in our particular solution. So what does our particular solution look like? Yp of t. Well, m is 2, so we have to have a general polynomial of degree 2. So we have a sub 2 t squared plus a1 t plus a naught. And then it's e to the power 0 t, but that disappears. And so we have cosine pi t. And then the second part, again, m is 2, so we have to have a general polynomial of degree 2, b2 t squared plus b1 t plus b naught. And then we have sine of pi times t. And again, because alpha is 0, our answer does not have e to the power in it. And that's our final answer. That's our form of the particular solution to part C. Okay, and then for part D, we have 5e to the power negative 3. So let's take a look at that. Let's see. So we're going to take a look at D. Oops. Let me get rid of this. Okay, and so now I want to take a look at question D, and the right hand side looks like 5e to the power negative 3t, and we're going to compare that with the general form. It's up here, ct to the power m e to the power rt, because there's no sine or cosine. So ct to the power m e to the power rt. And there's no power of t on the left-hand side, but we can write this as 5 times t to the power 0, and then e to the power negative 3t. So what we learn from that is that m is 0 and r equals negative 3. Now, r equals negative 3 is a root of the auxiliary equation, and it's a simple root. So it means that s equals 1, because this is a root of the auxiliary equation. We saw that up here, r equals negative 3. Okay, so our general solution then looks as follows. So we have yp of t equals general polynomial of degree 0 is just a constant, a naught, and then times e to the power negative 3t. But now because we have that root, we then have to multiply this by t to the power 1. And of course, that can be simplified to just yp of t equals a naught t e to the power negative 3t. Okay. And that's our final answer to part D. Okay, let's finish up the last two ones. So part E, the right-hand side is 3t e to the power t, right? That's the right-hand side of our differential equation. So we have 3t e to the power t. And now let's compare that with our general form, ct to the power m e to the power rt. And we see that m is equal to 1. And we see that r equals 1. Now, r equals 1 is a root of the auxiliary equation, and it's a simple root, or a root of multiplicity 1, so that means that s equals 1. Okay, our particular solution then looks as follows. Yp of t equals degree of t is 1, so we have to have a general polynomial of degree 1, a1t plus a naught. Then we have our e to the power 1t. And then because of it being a root of the auxiliary equation, we multiply by t to the power 1. And we can simplify that, right, as follows. Yp of t equals a1t squared plus a naught t times e to the power t, Just distribute that t over those two terms. Okay, and then the final one, t squared times e to the power t. We have to compare that to the general form of f being of the form c times t to the power m e to the power rt. Here we see that m equals 2, r equals 1, and just as before, we have that it's a root of the auxiliary equation, so we have s equals 1. And so our general solution, or the particular solution, looks as follows. Yp of t equals degree of a polynomial with degree 2. So that's a2t squared plus a1t plus a naught times e to the power 1t and then we have to multiply by t to the power 1, or just t. And so yp of t is a2t cubed plus a1t squared plus a naught t times e to the power t. That's the form of the particular solution. And that concludes our video.